Hello everyone, hello my lovely students, welcome back to this video session. My name is Yashwant and I'm from India, which happens to be a very awesome, wonderful country. And today I have got an amazing math lesson for you all. Want to know what's that? Then please don't skip and make sure to stay with me till the end. Here we go. So today we're going to talk about trigonometry. And more specifically, we'll talk about trigonometric functions or trigonometric ratios, whatever you feel comfortable with, you can say for a right angle triangle. Now, before we get into details, I expect from you all that you guys are familiar with this word trigonometry. Hope so. No worries. If you don't know, I'll say it for you. So this word trigonometry is actually derived from two Greek words. The first one, trigonon, and the second one is metron. The word trigonon means triangle and the word metron means measure. So this branch of maths, trigonometry, actually talks about the measurement of sides and angles in a triangle. So coming back to our main area of discussion, we have got a total of 6 trigonometric functions or 6 trigonometric ratios, whatever you feel comfortable with, you can say. And we're going to define these trigonometric ratios for a right angle triangle. I have listed all these 6 trigonometric ratios with their full name and definition. We'll have a look at each of these trigonometric ratios one by one. So the first one is sine of angle. It is defined as perpendicular upon hypotenuse. Then we have cosine of angle and it is defined as base upon hypotenuse. Tangent of angle and it is defined as perpendicular upon base. Now we have their reciprocals. The reciprocal of sine of angle is cosecant of angle and it is defined as hypotenuse upon perpendicular. Then we have secant of angle, which happens to be the reciprocal of cosine of angle and it is defined as hypotenuse upon base. Then we have cotangent of angle, which happens to be the reciprocal of tangent of angle and it is defined as base upon perpendicular. Now these are all the full names of the trigonometric ratios and we usually don't write them in their full name. We have their short form as well. Now let's get back to the short form of trigonometric ratios. So just we have discussed the full name. Now these are the abbreviated form of the trigonometric ratios. So for sine, we have sine of angle and its definition is perpendicular upon hypotenuse. And I have written the short form of perpendicular and hypotenuse as well. So sine of angle is P by H. Cos of angle is B by H. Cos is the short form or the abbreviated form of cosine of angle. Then for tangent of angle, its short form is tan of angle, perpendicular upon base. Cosecant of angle, the short form is cosec of angle and its definition is H by P, hypotenuse upon perpendicular. Then for secant of angle, we have its short form as sec of angle and the definition is hypotenuse upon base, H upon B. And the last one, for cotangent of angle, its short form is cot of angle and the definition is base upon perpendicular, which in abbreviated form is B by P. One more thing I would like to specify here, that all the trigonometric functions or the trigonometric ratios are followed by some angle. Okay, it makes no sense if you don't write the angle. Like if I write only sine and I don't write anything after that, it makes no sense. So always there has to be some angle here. Okay, it can be anything. It can be like 30 degree or it can be like sine 60 degree or it can be like sine 57 degree. Any angle it can be. Now let's understand how do we use these trigonometric ratios for a right angle triangle. For this purpose, let's say we have a right angle triangle ABC, which is right angled at B. Now, as we all know, the side which is straight away opposite to the right angle is the longest side and it is called hypotenuse. Let us represent it using the symbol H. Now, which side will be called as base and which side will be called as perpendicular. Now many of you would be wondering to say this as a base and this one as perpendicular. But my lovely friends, this is not the case when we are defining trigonometric functions. Alright? So which side we should call base and which side we should call perpendicular, that actually depends on the angle with whose respect we are going to define the trigonometric ratios. So there are two possibilities now. Let's say this angle is alpha and let's say this angle is beta. We use the symbols alpha and beta very often in trigonometry to represent the angles, and we'll discuss two scenarios. Okay, so first scenario, if we define our trigonometric functions or the trigonometric ratios with respect to this angle alpha, which is angle ACB, alright. And the second scenario is if we define our trigonometric functions with respect to angle beta, which is angle BAC. So there are two scenarios. Okay. So the side which is straight away opposite to the right angle is hypotenuse. We represent it using symbol H, and this will be same for both the scenarios. For this as well, we have hypotenuse as AC. Now, the side which lies in between the reference angle, which in this case is alpha, and the right angle is called base, which we represent using symbol B. And the left one is perpendicular. If we talk about this scenario, in this case, the reference angle is beta. So the side that lies in between the reference angle and the right angle will be called as base. So this is base for this triangle, and the left one is perpendicular. Now we define the trigonometric ratios one by one. Let's define sine alpha. So the definition of sine is P by H, perpendicular upon hypotenuse. With respect to angle alpha, you can see perpendicular is AB and the hypotenuse is AC, right? Now if we define sine beta for the same triangle, now the reference angle is different. Okay, the triangle is same. Okay, the triangle is same. The triangle is ABC, right angle triangle ABC, but we are defining trigonometric ratios for different angles in the both scenarios. Alright, so the definition of sine is perpendicular upon hypotenuse. With respect to beta, the perpendicular is BC and the hypotenuse is same, AC. So you can see in both the scenarios we are defining sine, but because the angle is different, so the ratio is coming out to be different. So you have to be very careful with it. A lot of students I have seen, they make mistakes while defining these in this situation. Now we define for cos alpha, the definition is base upon hypotenuse, B by H. Now for this triangle, base is BC and the hypotenuse is AC. Now let's define cos beta. The definition is B by H, and with respect to beta, the base is AB and the hypotenuse is AC. Now tan alpha is perpendicular upon base. For this triangle, the perpendicular is AB and the base is BC. Tan beta, the perpendicular is BC and the base is AB, P by B. So I would like to specify here that you have to memorize all the trigonometric functions or the trigonometric ratios with their definition. Like the definition of sine is perpendicular upon hypotenuse, cos is base upon hypotenuse, tan is perpendicular upon base, and their reciprocals. But while you are writing them for a question or when you're applying them, you have to be careful and you have to look for the proper perpendicular and base in the triangle. Like you can see here, the perpendicular is different for both the triangles because the angle, it actually depends on what angle you are defining the trigonometric ratio. Now let's understand how to apply these trigonometric ratios that we have just studied in realistic situation. For this purpose, we have got a question. Pause the video, read the question carefully, and then we'll move to the solution part. Alright, so we have a triangle ABC which is right angle at B, and let me draw the triangle for you so you'll get a better feel. So we have this triangle ABC which is right angle at B. Right angle at B means the vertex B contains the 90-degree angle, and sine of A, it is given to you as 3 by 5. Sine of A is given you as 3 by 5. You have to find the value of BC and AC, and it is given that the length of AB is 20 centimeter. Okay, so we have to find the length of BC and AC. So how do we start? Okay, first mark the angle A. So this is our angle A. Now with respect to angle A, we'll define sine. So this angle is the reference angle and this is the right angle, and we all know the side that lies in between the reference angle and the right angle is called base. So this is our base. Let us represent using symbol B. And the hypotenuse is the side that lies straight away opposite to the right angle, which represented using symbol H, and the left one is perpendicular. Alright, now sine of A is 3 by 5. So the definition of sine is, sine of A is 3 by 5, and the definition of sine is P by H, perpendicular upon hypotenuse. So perpendicular in this case is BC and the hypotenuse is AC. So we'll write BC upon AC is equals to 3 by 5. Okay, now many of students, they do what? After this step, they say BC is equals to 3 and AC is equals to 5, which is actually wrong, very wrong. Okay, the students who do this type of mistakes, they actually they are not familiar with the concept of ratio and proportion, which I'm just going to tell you right now, because I don't want you all to make this type of mistakes. Alright, so just try to understand BC upon AC is equals to 3 by 5. It is actually the ratio in the simplest form. I'll take some realistic examples. Let's say I say you BC is 30 and AC is 50, and you find the ratio BC by AC. Okay, it will be 30 by 50, 3 into 10 upon 5 into 10, you get 3 by 5. Let's take one more situation. Let's say BC is given you to be 6 and AC is given you to be 10. Now you find the ratio BC by AC. So BC is 6 and AC is 10. If you simplify, it will be 3 into 2 and 5 into 2, and 2 and 2 will get cancelled out and you will get 3 by 5. Let's take one more example. Let's say you have BC is equals to 12 and AC is equals to 20. Okay, and you find the ratio BC by AC. It's 12 by 20. So 3 into 4 upon 5 into 4. You get 3 by 5 again. So you can see BC and AC have different values, okay, but still we get 3 by 5 in the simplest form. If you observe carefully, there is something which is common in all the three examples. What is that? See, something is getting cancelled out from the numerator and the denominator. Okay, so this common part is different for the three situation, but it is same for numerator and denominator both. If we generalize this, I can say BC upon AC is equals to 3 into K upon 5 into K, where K is any positive real number. Alright, so we can represent this common factor which is getting cancelled out from the numerator and denominator as K. So the proper way of representing this situation is, whenever you come across this type of situation, let's say you get x upon y is equals to, let's say you get 2 by 7. So better you should write x is equals to 2k and y is equals to 7k. This concept is taught in the chapter ratio and proportion. So similarly, for this question as well, we're going to write BC is equals to 3k and AC is equals to 5k. Hope you understand. So now we have BC is equals to 3k and AC is equals to 5k. Okay, let's represent them in our figure. BC is 3k. Okay, so this is our 3k, the perpendicular, and AC is 5k, the hypotenuse. Okay. Now let's find the base. We have the Pythagoras theorem, h square is equals to p square plus b square. So we will find the base with the help of that. So h square, 5k square, p square is your 3k square, and b we have to find. So if we simplify this, we get 25k square is equals to 9k square plus b square. We bring 25k square minus 9k square is equals to b square. So we get 16k square is equals to b square, or b square is equals to 16k square. That means b is your 4k. So the base comes out to be 4k. Alright, so the base comes out to be 4k. 4k. We have to find the value of BC and AC. BC and AC, we have to find the values. Now the value of BC is 3k and the value of AC is 5k. So we have to get the value of k if you want to write BC and AC. For that purpose, the question has given us information AB is equals to 20 centimeters. So AB is your base here, which is 4k actually. So the value of AB is 4k and it is equals to 20. So the value of k comes out to be 20 by 4 and it is 5. So k is 5. Now if we put the value of k, as 5 here, so it will be 3 into 5 and it will be 5 into 5. So 3 into 5 is 15 and 5 into 5 is 25. So the value of BC comes out to be 15 centimeter and the value of AC comes out to be 25 centimeter. That's all. So coming back to the second question of today's session, we have a right angle triangle OPQ, right angle at P. That means the vertex P contains the right angle. I'll draw the figure so that you can get a better clarity. So we have this triangle which is right angle at P, OPQ. It is given to you that OP is 7. So this is our OP, it is 7. And OQ minus PQ is equals to 1. We'll come back to this in a short while. Just concentrate on what we have to find. We have to find sine of Q and cos of Q. Sine of Q and cos of Q. So the trigonometric ratios are defined with respect to angle Q. Let's mark the angle Q in our triangle. So this is our angle, reference angle. Now with respect to this angle, we'll first identify perpendicular and base and hypotenuse also. Hypotenuse is fixed. This is hypotenuse. It is opposite to the right angle. Now the reference angle and the right angle contains this side PQ. So this will be your base and the left one will be your perpendicular. So in this case 7 is your perpendicular. Okay. So now let's get back to this value. OQ minus PQ is equals to 1. OQ minus PQ is equals to 1. Let's use this information. OQ minus PQ is equals to 1. It can be written as OQ is equals to PQ plus 1. Now if we want the value of sine Q, the definition of sine Q will be sine is perpendicular upon hypotenuse, P by H. With respect to angle Q, perpendicular is, you can see, OP, whose value is 7, and hypotenuse is OQ, which is not known to us. For cos Q, the definition is base upon hypotenuse, B by H. And with respect to angle Q, the base is PQ and the hypotenuse is OQ. Now we have to get the values of OQ and PQ. We have to get the values of OQ and PQ. Okay, now we'll use this information. OQ is equals to PQ plus 1 and the 7 centimeter which is given to us in the question. Let's say PQ is equals to X. Then we have OQ is equals to X plus 1. Okay, PQ is X. So we have taken base as X and the hypotenuse will be your X plus 1 then. Now if you use the Pythagoras theorem, which says H square is equals to P square plus B square, let's see what we get. We have X plus 1 as the hypotenuse and the value of P is 7. So we have 7 square in place of P square, and for B square we have X square. Left hand side we open using the identity A plus B whole square, which you all must be knowing. A square plus B square, 1 square is actually 1, and then we have 2AB, 49 plus X square. We can cancel X square and X square. Now then we have 2X is equals to 48. And we have X is equals to 48 upon 2, which is coming out to be 24. So the value of X comes out to be 24. Alright, so we have 24 as the base and 25 as the hypotenuse. So it's actually 7 upon, so sine Q comes out to be 7 upon 25. 7 upon 25, and cos Q comes to be 24 upon 25. 24 upon 25. That's all for this question. Okay, so this is our last question of today's session. We'll solve it and then we'll end the session of today. We have sec alpha is equals to square root of 2. Then we are supposed to find out the value of 1 plus tan alpha upon sine alpha. Now this is a really different question from the previous questions that we just did. Okay, so we'll find out the values of tan alpha and sine alpha with the help of sec alpha, and then we can easily get the value of this expression. So how to do this? Alright, so we know that the reciprocal of sec alpha is cos alpha. because they are the reciprocal of each other. So the reciprocal of cos alpha is sec alpha. Alright, so the value of sec alpha is root 2. So we'll write root 2. So cos alpha is actually your 1 by root 2. Now we can draw the triangle. Let's say we have this triangle, right angle triangle A, B, C, which is right angle at B. And this is our angle alpha. So with respect to this angle alpha, the base is BC, because the side that lies between the reference angle and the right angle is called base. The side which is opposite to the right angle is called hypotenuse, and the left one is perpendicular. This is how we identify the perpendicular base and the hypotenuse for a right angle triangle. And for these type of questions, even if the triangle is not given to you, for solving such type of questions, it is advisable to just assume a triangle, and the angle that is given to you is actually the acute angle with whose respect the trigonometric ratios are defined. In your syllabus for 10th class standard, the angle is actually the acute angle, because we are defining the trigonometric ratios for a right angle triangle. So in right angle triangle, we have one right angle and the remaining two angles are acute. Alright, now cos alpha is 1 by root 2, and the definition of cos alpha is base upon hypotenuse. For this triangle, we can see base is BC and the hypotenuse is AC, 1 upon square root of 2. A couple of moments back, we have discussed about the concept of ratio and proportion. As per that concept, we can write BC is equals to 1 into K and AC is equals to square root of 2K. So 1 into K is actually your K. Now BC is your base, so the base is K, and the AC is your hypotenuse, which is actually square root of 2K. Now we can use the Pythagoras theorem to get the value of P. Pythagoras theorem says h square is equals to P square plus B square. So the value of h is square root of 2K, and the value of P, we have to find the value of B is K, so K square. So we get 2K square is equals to P square plus K square. On further simplification, we have P square is equals to K square. So the value of P comes out to be K. So P is also same as the base, so P is also K. Okay. Now P, B and H all are known to us in terms of K. Let's find the value of tan and sine. So the value of tan alpha, tan is defined as P by B, perpendicular upon base. For this question, perpendicular is AB, whose value is K, so we'll write K, and the base is BC, whose value is K. So the value of tan alpha comes out to be 1. Now let's find the value of sine alpha. Sine alpha, sine is defined as P by H, perpendicular upon hypotenuse. So we'll write P by H. For this triangle, P is AB, whose value is K, and the hypotenuse is AC, whose value is the square root of 2K. K and K will get cancelled out. We get 1 upon the square root of 2. Just let me erase this. This is quite small, you won't be able to see it properly. Okay, so we get 1 upon square root of 2 as the value of sine alpha. Now we can put the values of tan and sine that we have just calculated in the expression that we want to find. So tan alpha is 1 and sine alpha is 1 upon square root of 2. So we have 2 upon 1 upon square root of 2, which comes out to be 2 root 2. So this is the final value of the expression that we want to find. and that's all. So this was all about today's session, and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones, and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming videos. See you all, my lovely friends, in my next upcoming videos with more exciting and awesome questions. Till then, bye bye, stay safe, and have a nice day.